All right, this is another method of solving exponential equations. This is used in specific cases, in particular when there's a variable only on one side. I'll show you what I mean. Here's the steps. Now it's actually quite easy. First thing you have to do is get the exponent alone. So the thing being raised to the power, that's this guy, right? So that needs to be alone, which means we're going to have to get rid of this guy. Well, when you're dealing with equations, the only way to get rid of something is to do the opposite, subtracting 5. So we have to add 5 to both sides. Now we're here. 2 to the x power equals 11. All right. The next step is to convert it to a log. You have this on one side, b to the x equals y. Remember, you identify the base. That's the first step. Here's the base. And then what happens to the x and the 11 is that they are going to swap sides. So when I convert this one, it becomes log the little base, right, in the basement. And then I'm going to switch places with the 11 and the x. Now I'm going to rewrite that the other way. I like my x's on the left. So here's what I've got. X equals log base 2 of 11. That's how that's written. Now log base 2 of 11 is not a number that you can just come up with. You're going to use a calculator, right? So you solve for x and you're going to use a calculator for the logs. Okay, one way you can do this is to open up desmos.com/calculator, and you just have to tell it, you literally just have to type that in. So we're going to type log base 2 of 11. This right here, I'm going to plug that into Desmos. Here's how it works. If you go down here where it says keyboard, over on the right side, it says functions. Stop it. And then under miscellaneous, you'll see this one that says log, and it's got a little a by it. And that's kind of key to this. So the little guy is 2. And then if you use the over arrow to get inside the parentheses and type your number, it gives you the value of that log. So if we were rounding to one decimal place, that would be 3.5 because the number after the 4 is bigger. So we would go to 5. So we would say x, and you use these squiggly equals signs to show that that's not the exact value, that that's an approximate value. This is how you would give an exact answer, but we're using the calculator to do those. Okay, the second thing you can use is a TI-84 calculator, the ones in the back by the phones. Here's what the keyboard looks like. If you'll notice right here, it says log, right? Now that's not log with a base, that's the basic log, which had a base of 10, right? So if you hit that one, and then you type in 11 and hit enter, that's not the right value, right? Obviously. We know it's supposed to be about 3.5. So you actually want to go right here into what's called the math menu. And if you see it says math and then it's got 1, 2, 3, 4, blah, 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 blah. If you push the down button until you get to the bottom, look at what this one says right here, log base. If you choose that one, see how it's got a little square down at the bottom, okay, put a 2 because that's our base. And then up inside the parentheses, hit 11 and enter, and you get that same number as we got before. So whether it's on the calculator or on Desmos, it doesn't matter. You just have to know the different keystrokes for each one. Okay, let's talk about this next one right here. This one's got an E. Now hopefully you remember that E automatically produces an ln, right? ln, if you guys remember it, right? ln. So you replace E with ln, and then these guys are going to swap places again. So 5 now goes over here, and the 2x goes on that side. I prefer my x's on the left, so I'm going to flip-flop these guys. I just mirror imaged it. ln of 5. Okay, back to that calculator. If you'll notice this button right here, that red one says ln, and you could type in a 5 and hit enter. That says it's 1.609. Let's just go with 1.6. So now we've got 2x equals about 1.6. To finish solving, you've got to divide by that 2, and you get x equals 1.6 divided by 2. So if we do 1.6 divided by 2, 0.8. Oops, 8, not 6. You could have also divided by 2 before you plugged it into the calculator. It doesn't matter where you plug it in. That'll give you your answer. And on Desmos, again, same thing. Here, though, this one's kind of cool because you can actually type in ln. ln parentheses 5. And then if you go outside of the parentheses and hit divided by 2, it will give you that same number. So it's all about which one you understand better. If you're okay with Desmos, that's one you can use anywhere. If not, you can use the TI calculators that are in the classroom. Okay, this one's nice and easy, but it's restricted to when there's variables in the exponent. This can only be used when there are variables, can't write and talk at the same time, variables in the power on one side. You can't use the other method if we have, or you can't use this method when there's variables on two sides, both sides. Let me show you. Like the ones we did yesterday was like 2 to the x equals, let's say 2 to the 4x minus 1 or something. This won't work. You can't do a transfer and turn it into this log form up there because there's too many variables in there. There's more than one in the power. So you cannot use it in this case. In that case, you would have to go to the other method that we were talking about. Okay, let's try some of these. This one also has to be used when you can't write similar bases, right? 16 cannot be written as 9 to anything or 3 to anything or anything that matches. So the first thing you're going to do is transfer it into log form. Here's your base. That's your b. These guys switch sides. So write the word log, put your little b down there, and then you swap. 9 now goes over here, and x goes over there all by itself. Okay, flip-flopping it using a mirror image. And we plug that into our calculator. On a smart calculator, we would go into math. Down at the very bottom, the one that says log base, choose enter. Our base was 16, and our number was 9. Looks like 0.79. We're going to round to one decimal place, so that's going to be 0.8. So x is approximately 0.8. Okay, this next one right here, a little bit different. Now we've got this 2. This is 2 times 3 to the x power. It is not 6 to the x power. This exponent comes before multiplication. Exponent first. So you cannot combine them. The only way to deal with this is to get rid of that 2. Since it's 2 times, you divide by 2 to get rid of it. So now it's at this place, 3 to the x equals 2. Now the exponent, the thing being raised to a power, is by itself. We can transfer it into a log. Okay, we need to identify our b. That's b right there. So I'm going to write the word log, put my b, the 3, down below, and swap places with these guys. 2 is on this side, x is all by itself on the other side. Mirror image, log base 3 of 2. We're going to plug that into the calculator and say that it's approximately, let's try Desmos this time, Desmos, under functions, miscellaneous, log base, log base 3 of 2, 0.63. If we round to one decimal place, that will be 0.6. All right, continuing on. This next problem, again, we've got to get the exponent by itself. This guy right here is the exponent. In order to get it by itself, we have to get rid of that 3. So I'm going to subtract the 3 from both sides. That gives us 4 to 5x power equals 16. Now you cannot divide by 4. Dividing by 4 will not take that x out of the power. You've got to switch it to logs. So I'm going to rewrite it. Here's my base. So I'll rewrite it with the word log and the 4 down there in that little spot. And then we swap these guys. 16 goes over here, and the 5x is by itself on the right side. Okay, we can plug in this log base 4 of 16 right here. We plug that into the calculator. Again, math menu. At the very bottom, there's one called log base. My base was 4. Inside was 16. Oh, that's 2. I knew that. So this is going to be 2 equals 5x. And to finish solving, sorry, I prefer to write it with the x on the left side. I should have done that in the beginning. So I'm going to mirror image these guys and say it's 5x equals 2. Get rid of that 5 by dividing. You get x equals 2/5 or 0.4. That one's not approximate. That one's exact because that log came out to be perfect. I don't know if you noticed it or not after what we talked about previously. This one right here, you could have also turned that 16 into 4 squared, right? And the bases match. Drop the base and finish solving. In that case, you could have used either. Either one would have been a perfectly acceptable answer because you would have got 2/5 in either case. All right, let's try this next one. We've got an E, okay? Automatically, I think ln, but we have to make sure this guy is alone first. So I got to get rid of that 1. That becomes e to the x minus 6 equals 4. Now I can switch it over. I'm going to change to blue just so you can see this. E becomes ln, right? These guys swap places. So the 4 is now over here, and x minus 6 is on the other side. Took this thing and swapped it out with the 4. I'm going to flip-flop. I like my x's on the left. It really doesn't matter, but I feel more comfortable that way. Okay, ln of 4, we can plug that into the calculator or on Desmos, doesn't matter. ln of 4, enter, is, we round it to one decimal place. Let's go 3, next number is 8, so 1.4. So x minus 6 is about 1.4. Got to finish solving, so I'm going to add 6, which means x is about 7.4. Okay, there's some basic examples, and that's kind of it. You get the exponent by itself, switch it to logs, and then you can use a calculator to help you figure out the rest of it.